I will show you how you can quickly install Xpress-Bio with all the dependencies on your host system. Xpress-Bio has been one of my projects that I worked last year. It's a real-time bioinformatics framework based on Node.js. It allows you to receive real-time information from your pipelines and relate to the client. It's a multi-tenant application. It comes batteries included with SAM tools, HDSlib, BCF tools, igv, and Blast, and it can easily be extended with extra routes and threads. It also comes with WebSockets and server-sent events out of the box that are both multi-channel and interoperable. That allows you to quickly integrate them with large language models as well. So you have two options. You can either install it bare metal on your host system, or you could follow along with me in a throwaway Docker container together. So I'll be working on Ubuntu 24. So the container that I'll be demonstrating everything will be based on of Ubuntu 24, but Ubuntu 20 and 22 is fine as well. If you're going to install it on the host directly, you have some prerequisites. Anything starting from Debian 10 is perfect. Again, likewise for anything starting from Ubuntu 20 is also going to work fine. So let's get started. I will first create a Docker container, but even then, before that, let me create a new pane at the right so that I can just smaller, that's better. And then I have a little file lying around here, so it reminds me the steps during recording so I don't forget all the important things that I need to do. So I'll create a Docker container, Docker run. We want to run it in the background. I'll give it a name. Let's make it XP test. Auto remove Ubuntu 24, and we're going to keep it open so that I can exit and get back in as a different user. Okay. Container bind to port 3000. Oh yeah, that's right. So we also need to bind to port 3000. Docker run background name XP test, remove port 3000, host 3000, Ubuntu 24, sleep infinity. Looks good to me. So we have a container running. I will get into it as root. And bash shell. So let's do updates. Don't do what I do. At least redirect the output of your commands to a log file or something so you have an idea if something goes wrong. For demonstration purposes, I don't want to flood the screen with unimportant lines, so I just gonna silence everything. Okay, let's do that. And then we'll need to install sudo and git. Now the installation, the Xpress-Bio will come with a bootstrapper script that will install all the dependencies for you. And the approach is a little bit different than the package managers that you use. For example, if you're used to using Conda and so forth, they bring in isolated binaries. In our case, we're going to be downloading SAM tools, BCF tools and whatnot, and we'll be building them for your system. Okay, so we will need to be a sudoer and we will need to install it system-wide. If you don't want to do that, you have installed SAM tools and Blast and etc. Through your package managers, you can skip this part of the video, go to the last 4 or 5 minutes where there's a JSON file and you can modify the paths to the folders that have those binaries, and that way Xpress-Bio will know where to use them. So just keep that in mind. If you're following along with me in this throwaway Docker container, just we have to install sudo and git. Looks good to me. Now you'll need to create a user. The whole bootstrapping process Shouldn't take longer than 10 minutes. Depends on your CPU and your internet connection. Okay, so we have sudo and git installed. Now we're gonna add a user with a home folder default as bash, and let's name it researcher. I think that's better. Researcher. Okay, we created the user. Clone Xpress-Bio. Yeah, but this user has to be sudo, so we'll have to run the script as a sudo. So I'll have to also make it a sudo. Researcher and all hosts as all users. No password and all comments. You normally don't do anything like this. You usually have a password and etc. But for demonstration purposes, I'm just going to keep it simple. Something like this. So let me see. Researcher, password, all. All right, looks good to me. And now we'll exit the container, and then I will get back in as researcher. And we want the default interactive file. You can already see it, just to test everything. See these, what we have now? We have nothing, just a bash configuration file, bash profile, and just a couple of files. Okay, the next step is to clone the repository. Yeah, let's do git clone. The default folder name will be Xpress-Bio. That's okay. Don't have to specify anything. Looks good to me. All right. Let's see what we have. Now, here, this is not your root folder, so you have the workflow, README, etc. So to get into the actual root folder, you need to go inside resources, Docker, and here you will see you'll have a Docker file as well. So if you want to build a Docker image of Xpress-Bio, there is your Docker file. I will go one level deeper, app, and this is your root folder. So here you have everything that you need. Your package.json, source, pipelines, JavaScript, and etc. Now, the Bootstrapper script is located under the bin folder. And normally you're not supposed to run any of these bash scripts manually. Xpress-Bio utilizes them through the process lifecycle. The only thing that you can use to help you get started is the initial setup.sh, and that's what we're gonna run, okay? So try running it first. You can make it an executable, something like this, but I mean, I'm in a throwaway container, so I'm not gonna do that. I'm just gonna run it like this. Okay, and you'll be greeted with a warning. Okay, so you have to be a sudo because we are gonna be pulling system-wide packages to be able to build Sam Tools and his friends. Okay, so I will now run it as a sudo, and it really doesn't matter your current working directory, where you run it from. But now I'm already in the bin folder, so I'm just going to run it from there. Okay, looks good to me. Now this will install some system-wide packages, some base tools that you will need and Xpress-Bio will need, such as curl, wiget, and then it will install the build dependencies. These are the packages that is required to be able to build Sam tools, BCF tools, etc. For Blast, NCBI luckily releases pre-built binaries depending on CPU architecture. So this Bootstrapper script is going to check your CPU architecture and will pull in the appropriate Blast version and the binary for you. Okay. The process takes around, as I said, 10 minutes, depending on your internet connection, depending on your CPU. I'm running everything on a mid-range laptop, so it's not really requiring a lot of hardware to get everything running. You could run this on a 10-year-old device, no issues with that. So what it did here, it briefly updates you. So it created a log file. So if you want to inspect, there is your log file. It creates a .local bin folder under your home directory. So everything that will be installed, all the binaries and blast and SAM tools, BCF tools, HTS-lib, they will all go under .local bin. Yeah, now it's asking you which tools you want to install. Now, currently Xpress-Bio comes with SAM tools, which includes SAM tools, HTS-lib, BCF tools, etc. And it will also install Blast, which is Blastan from NCBI. In my case, I'm inside a throwaway Docker container, so I have nothing. Will be installing both of them. In your case, if you don't want the installer to install one of or any of these tools, skip to the last 5 minutes of the video. There will be a JSON file that will have paths to the folders that will have the binaries. And you just have to modify those paths and you'll be good to go. Okay, in my case, I will use both of them. So to toggle and select these options, you can either hit the X key or the space key. I will toggle SAM tools and Blast and I will hit enter and it will start installing and downloading all the necessities for SAM tools. So it will first download, I think, SAM tools, HTS-lib, BCF tools, and then it will start building them. Shouldn't take really long. The longest step is the SAM tools and also downloading the Blastan from NCBI. For whatever reason, sometimes the download goes really fast, but sometimes you get stalled and the download goes really slow. So those are the real limitations. Now it's building HTS-lib, and lastly it will build SAM tools. After we run the initial setup, I'll have to install Node because we don't have Node. Ubuntu base image does not come with Node installed, so we'll have to install Node, and then we'll have to install the packages through npm install, and then we should be good to go. This bootstrapping process of running the initial setup.sh, you only do it once. So if you're installing it on your host system, you just do it once and then you have all the dependencies there. Our last step is building SAM tools, and then it will start downloading the NCBI Blast. Luckily, NCBI Blast releases a large variety of pre-built binaries. So the bootstrapper will first check your CPU architecture, and then based on that, will download the right one. But in certain cases, when the binary doesn't exist, you will receive an error message from the bootstrapper script. Also, the script is gonna add a few blocks into your bash RC. Okay, you can move these blocks anywhere as you want, as long as you don't disrupt the starting header and the ending header. So because it's modifying your bash RC, as you can see, it backs up your bash RC as well. If something goes wrong, something doesn't go according to the plan, you can always restore it. Otherwise, you're safe to delete that one. And this process here now is downloading Blast 2.5. This is not the newest version, but it's totally tested with Xpress-Bio. I think you'll be also okay with the newer versions. You can just flip the path on the JSON file, and then Xpress-Bio will use that version of the binary that you want it to use to. The downloading process is the one that is a little bit strange. Sometimes it goes really, really fast, and sometimes it goes really, really slow. Okay, so now it's extracting the binary under the .local bin. All right, so it also tests if the final bash script is sourceable. It installed it under .local bin CPI Blast 2.5/bin. It also creates a initial setup.config JSON file. So you can modify this JSON file, remember in the beginning of the video, to modify the paths to point to the binaries that you prefer if you don't want Xpress-Bio to install something, for instance. It starts memcached, and now we're back. So what I'm going to do, I'm going to exit, and then I'm going to get back in. Okay. So let's try SamTools version. There you go. Let's try Blast version. Be careful with Blast. You need to put one dash. I don't know why, but it's like that. igv version. There you go. Okay, so all of the binaries are available. So the path is there. You can also take a look at your bash script to see what it did. We can actually do that. Have a look. So it creates two blocks. You can move them around, and you can change them if you want to. All right. Now I need to install Node. Right. Okay. Normally, base image Ubuntu 24 does not come with curl, but since we ran the bootstrapper, all the necessary basic packages that you would need are also there. So we have curl. I can use that. Also, I think forgot to clone the repository. No, I think we cloned the repository. Otherwise, how would I run the bootstrapper? Okay, I just need Node. Right. Node. Dep.node source setup 20x. Now Xpress-Bio requires Node 20 LTS. As of recording, it's not going to change anyway. 2019, okay. But I have tested Xpress-Bio with Node 20. You should have no issues running it on 2022, also on 24, and even 25. Took a look at the breaking changes. I don't see any issues with anything that could interfere. If you try it out and you get into a trouble or if something doesn't work as expected, let me know. Open an issue on GitHub. You can find me on Twitter, etc. Okay, now we're going to do it like this. Don't do this, okay? Normally, this kind of thing is frowned upon. You usually want to have an idea of what you have downloaded and what you're executing. But in this case, for demonstration purposes, I'm just gonna execute it. And also, again, don't do this because you have no idea what went wrong. At least write it to a log file. Don't want to flood the screen, so I'm just gonna check this command one last time. dep.nodesource.com setup underscore 20x sudo dash. Looks good to me. This is not going to install Node, so we'll have to now install Node. And for that, we'll also be using apt-get. So I need to be a sudo apt-get install y node.js dev. Okay. Well, during Node installation, so if you're installing it on your host system the first time, you probably you have already Node version manager or something like Mize lying around. So you would never do these steps, okay? What you would normally do is something like nvm use 20 or Mize use -g node 20, etc. So in my case, I'm in a throwaway container, so I'm just doing it in the quickest way possible. Also, when you are first time installing Node, it will ask you for time zone questions and etc. So I have to suppress them. And for that reason, I need to pass, I think, two environment variables, Debian content, usually non-interactive. And also for the time zone stuff, something like this should do. So let me take a look at the command. Sudo env Debian frontend non-interactive tz. Okay, get install y node.js dev null. Looks good to me. Okay, let's give it a try. Yeah, we have Node version 20. Okay. So we installed Node. We have all the dependencies installed. Now the last thing that we want to do is to get inside Xpress-Bio. Remember, the root folder is not directly under Xpress-Bio. The root folder will be resources docker app. This is your root folder, and have a look at the package.json. It's not really bloated. Minimal amount of packages, as lean as possible, but feature packed, and will allow you to get quickly up and running with WebSocket server sentiments and all the things that you can do to enhance your pipelines and also get started with integrating large language models. I tried to design it as unopinionated as possible. Let me install quickly with npm install. Did it have a silent flag? I have no idea. I don't remember. Something like that. I don't know. Let's go like this. These two packages are from Jest, the testing framework. So I'm using, I think I'm using Jest 29.7. So I will update that to 30, but all of the other packages are quite up to date. Now we have npm installed. One thing that I want to show you before I start the application is if you go inside the JS server, here you'll see that it already comes with server.config.json, and then after we ran the bootstrapper script, we have now initial setup.config.json. You can have as many .config.json files as you want. They will be alphabetically sorted and then deep merged on runtime. So that way, if you have multiple servers running different versions of Xpress-Bio, you can layer the configurations based on the server needs. I find that very useful, at least for my case. Here, if you take a look at the initial setup.config.json, you will see it's a one object with executables key, samtools, bgzip, tabix, blastan. They all point to the folders. Be careful, folders that have the binaries. So if you have opted out of installing samtools or blast via the bootstrapper, and you want to use your own binary, this path should point to the folder that has the binary, not the binary itself, okay? And that way, Xpress-Bio will be able to find and utilize that file, okay? That being said, we can start the application. Now, to start the application, you don't do npm start or anything like that. You need to go up one level. So under the bin folder, you will have a script called start.sh. So you will do something like, you can make it an executable again, but I'm not gonna do that. Okay, so in my case, I'm in a throwaway container. Okay, so I will pass an additional argument to basically, it signals the script to say, hey, don't make any assumptions on the environment that you're running. I won't go into detail, but if you look inside the script, well, let's have a look. Maybe at some point, it's going to check if it's running in a container environment, and if it detects that it's in a container environment, it's going to switch to a non-privileged user called IPv, and then will run everything. Now, the problem here is it will automatically assume that the container that it is running in is the container that is built via the Docker file, which has a non-privileged user called IPv. It's a name from my past software. So basically, you don't want it to make that assumption. Okay, to force that into starting normally, you pass the argument. So if you have been following along with me with the throwaway Docker container, pass the same argument. If you're running it on your host, or if you're running it as a Docker container, you don't have to pass that option. That's not necessary. Okay, so we're going to do ignore container. And now the app is running, okay? The output is a little bit verbose. You could have redirected that to a log file or just silenced it, but I prefer to go over all the information that it outputs for you so that you have an idea of what's going on. So first of all, it gives you the final configuration. There you go. And here, your final configuration file. And then this is the deep merged final configuration. So it means, for example, in the server.config.json, there's nothing like this, but they come from the initial setup.config.json. So you have extra other information, mode, version, whatnot. These are the binaries you can request. You normally don't use them, requestable files. This is not a dynamic list, but gives you an idea. Creates session variables if you didn't provide in the environment variables for that. Loads the routes, starts 4 threads. So Xpress-Bio comes with 4 threads. These are long living threads. They start with the application. They terminate with the application. The first one is for getting system information live and feed it to the client. The second one is for downloading resources. The third one is for indexing. And the fourth one is for blast. Creates home folders if not existed. So if you can start a Docker container with bind mounts, and if it detects the folders, it will not recreate them. So for example, you can have a bind mount of an FA folder, and then it will not recreate this folder and it will use the files inside that folder. Xpress-Bio has a couple of folders. These are semantically designed. So BAM files go under BAM folder. BAM indexes go under BY folder. FASTA files, your sequences, goes under the FASTA folder. FASTA indexes goes under the FI folder. Anything that is compressed, .lz4, tar gz, they all go under the gz. The bgzip, they all go over here. These are the index files, CSI and TBI from the BGZ files. The GFF files, your general feature format files, they go under here. Temp is for you, and for also temporary processes that Xpress-Bio, temporary files that it creates, they're all created here. Xpress-Bio creates a temporary folder for every operation it does, so you can use it for yourself as well. There's no chance of clashing, so you could use that for you. Blast searches, they go under blast DB and blast query. So it makes a little check, and then it listens on all addresses. Now, this is the interesting part. We pass the option ignore container, and you would assume it would then start listening on localhost. But no, the ignore container is consumed by the bash script. The underlying node process will still check if it's running in a container-like environment, and if it detects one, it will say perhaps it's a good idea if I listen to all addresses. So you're still listening on all addresses. And let's quickly have a look at the application. Let's refresh. And the application is running. Now, of course, you have no files here. You have server-sent events feeding data live to the client. You have large language models. You can pass in your token here and start using it. You have WebSockets out of the box, a little chat box for researchers to communicate, and everything else. If you want to bring in files and FASTA files and etc., you have the option to pass a URL. All in all, you're now ready to go. Everything is set up. WebSockets, server-sent events, everything out of the box. And I think this is all I wanted to show you today. To deep dive into the features, that'll be in a separate video. And thanks for watching.